So we're going to do example 3, which is modeling trigonometric data, again, for something that has to deal with temperature and the weather. So this says the following table shows the average monthly temperature in Cleveland, Ohio, based on the data from 1971 to 2000. Since average temperatures are not likely to vary much from year to year, the data essentially repeats itself the same pattern in subsequent years. So a periodic model is appropriate. First, we're going to make a scatter plot of the data. So I'm just going to pause this to make the scatter plot first. So I made a scatter plot of my data, and I highlighted the minimum and the maximum value in my table. So for this, it says find a sinusoidal function that models the temperature by hand. So for this, first we need to figure out what the amplitude is. So the amplitude, remember, is your maximum, which is 71.9, minus your minimum, 25.7. Divide that by 2, and we get 23.1. Your midline is your maximum plus your minimum divided by 2, which gives us 48.8. And for this, the period of my graph, because we're talking about the months, is going to be 12 months. And so the key points would be equal to 12 divided by 4, which is 3. We don't need that right now, just quite yet, but we do need the b value. So remember, the b value is equal to 2 pi divided by the period, which is 12, so pi over 6. And now we can use that to help write our equation. So for this, if I think about my midline being at 48.8, that would be somewhere in between 45 and 50, so somewhere in here. So if I look at that, I can see my minimum, we said, was at January, and my maximum in July, so up here. So I'm going to start with a cosine graph because I can use a phase shift of 1. So that would be negative because it's starting down here. So y is equal to negative my amplitude, which is 23.1, times the cosine of my b value, which is pi over 6. And then because my minimum is starting at January, so a phase shift of x minus 1, plus my midline, which is 48.8. So this would be one possible equation that I could use. And then if I think about my key points being 3, so if I have a minimum at 1 and I add 3 to that, so 1 plus 3 would give me 4. So my next key point would hit here on my graph. So if I would actually draw this in and make a curve, it won't fit the data exactly, but it'll be close to it. So I would get y is equal to, and if we're starting here, it'd be a positive sine graph. So amplitude would be positive 23.1 times the sine of pi over 6 times x minus 4, because we'd have to move our graph to the right 4, plus 48.8. Of course, there are other possible answers that we could have, but these are just 2 of them. So these are the equations we get by hand. Now we can also make a scatter plot on our calculator and use the sign regression to help us figure out what the data is going to be. So let's go ahead and do that. So next you want to go to your calculator. Of course, we're making a scatter plot. So go to Stat and enter on Edit. And you're going to enter your months into list 1 and the temperatures into list 2. So now I've plugged them into list 1 and list 2, and I always like to check over my values to make sure I didn't enter something incorrectly into the calculator. So after you do that, then remember to come up with the equations. You can go to Stat, and now we're calculating. And if you scroll down, you will see at the bottom, for right here, you get sign regression. So that's what we're calculating. So I'm going to hit enter on that. So for iterations, I'm just going to leave it at 3. So we're in list 1 and list 2. Don't worry about the period right now. So then we're going to store this regression equation into our y equals. So remember to do that. You go to vars, which stands for variables, y vars, which is y variables, enter on function, and I'm going to put it into my y1 and hit enter. Now, when you're doing your sign regression in your calculator, notice that the equation's a little differently than what we have because they didn't factor out the b value here, so they leave it in there. So that it means our phase shift looks a little bit different. So we would actually have to factor out the B to see how closely it matches what we have. But now I can go ahead and write this equation down on my paper. So now I just wrote down my equation from what I got in my calculator, and I wanted to check what the period was according to my calculator. So 2 pi divided by b, which is 2 pi divided by 0.5018 gives us the period, which is about 12.52. So this, notice that our calculator is making it so that we're trying to hit as most data points as we possibly can as we're making our sinusoidal function. So just kind of look at this, we know that our equation probably is a little bit more accurate because we're actually using a period of 12 versus the calculator that's making the period into 12.52. Now, of course, the reason I didn't put in when we were calculating the equation, the period to be 12 is because some of the older calculators don't do that. So then rather than putting in to make it so that we have the same thing, that's why I just left it as nothing. So for this, if I wanted to actually look at my graphing calculator, remember I can look at the graph and hit zoom 9 on here for the scatter plot. Oops, and I got to turn on this dot plot first. So if I go to my y equals, or second y equals, got to turn that stat plot on. So then hit zoom 9, and there's my graph, and this is the calculator equation that they came up with. So it looks like it's a pretty good fit. We could also put our equation in just to check it if we wanted to as well. Ours might be a little bit different, like I said, because we did it by hand. But as you can see, by hand or using your calculator will give you two good equations. So for this, we can see that the period is different. That's how they different from one another. And also the phase shift was different. It was not factored out here. So the period and the phase shift. So then it says use a calculator model to predict the times of year in which the average temperature is 45 degrees Fahrenheit. So that's why I wanted to look at the scatter plot on my calculator. So looking at this, if I want to predict when it's 45 degrees Fahrenheit, I would want to go to my Y2 now and plug in 45 and hit graph. And then, of course, I needed that other equation in my y equals so that I can look at the intersection. So if you don't have that other equation, your y equals, you would want to make sure that you put that in there. So now I can go to second trace and do the intersection and scroll to close to the point of intersection and just hit enter twice or 3 times, sorry. So we get about 3.7. So that right there would be the first point. And if I do it again, second trace intersection and go to the other side. And then I'm going to hit enter 3 times. I get about 10.6. So now I can see that from my graph, I just made it a little bit bigger right here. So we have late March and October are the times in year where the average temperature is around 45 degrees Fahrenheit, which makes sense for Ohio.